Chris is the founder of Blox that brings manufacturing to construction. A simple way to put it. I hope that's not too bad. And with a particular focus on medical modules, which obviously is extremely timely these days. So look forward to learning more about Blox, your vision, and how you are getting there.
Thanks, Martin. Amy, it's good to see your face. I don't know if I'm supposed to be on video, but it's not letting me start. It says you're blocking me at this point. You want to allow me to video? Martin, you got, okay, great. So prefabrication has been the holy grail of architects since Henry Ford. It's really hardly a new idea. I know a lot of us think so. My father reminds me frequently that it was around when he was young. The challenge is not, can you make something off site? The challenge is, can you make it make sense? And what this picture represents to me is, interestingly, it's an ecosystem. We've heard that discussion quite a bit over the last few speakers. Not letting me advance. Okay, so this is an LG washing machine, and I put this slide back in after hearing some of the other conversation, but they make this in South Korea by the tens of thousands. It can wash a household of teenage boys' clothes perfectly, and when it's finished, they're pretty much sanitized and ring dried. Okay, it can do all of this if it has 4 available standard components, attributes: power, water, space, and discharge. So power, water, space, and discharge, if it has those, this thing will work in Korea, it'll work in New Jersey, it'll work in Palo Alto, and it'll work on my front porch in Alabama, no problem. In the absence of any one of these 3 attributes, it is a very expensive, complex paperweight. So the point is that for industrialized construction to work, it needs an ecosystem to tie it together. So in 2008, we had an architecture company, we still have, and it's doing a number of things that are challenging. We had just gone from kind of a land of plenty to a land of emptiness, and it gave me time to work to rethink what we were doing as an industry. And so we started with what the future state is of what we wanted to be by understanding what the current state of the architecture, engineering, construction world was. And so the future state was not this siloed AEC industry that we have. It was designed, or it was thought of or envisioned as something that was different. We called it design, manufacture, construct, and we replaced nouns with verbs, with the notion that we would go from architecture to design and action, that we would add manufacturing because intuitively, even though we hadn't figured anything out about it, we knew that it was an incredibly important component, and we would go from construction to construct, and we would think of these things as a singularity as opposed to 3 discrete pieces that happen in a flow. And when we began to do that, we started with trying to manufacture and lever existing manufacturers. And we found that we were too immature as an industry to get them to adjust their methodologies and processes to make sense. And so there was this kind of lack of communication. We worked through those pieces and created essentially a singularity that's more than the sum of their parts. And its aim is really simple. It says, we're going to teach a legion of designers, something I know something about, how to leverage manufacturing, which we parenthetically have to help invent, so that we can simplify construction substantially. And we have to do all of these things so that they inure to a notion of 2 by 2 by 2. It's our moonshot. It's this notion that things have to be twice as good, objectively and subjectively, from energy and carbon footprint, human productivity, efficiency, all of these things elegantly resolved into something that ends in something beautiful that can be delivered with twice the speed, as measured in an objective time frame, which is total lead time. Imagine the idea converted to a certificate of occupancy, right? So that is our lead time. That is the metric that we check on. And we need to do this in such a way that the resultant of 1 and 2 creates twice the value. And if we can do that, then the future state of the AEC would be pretty relevant and compelling. The current state goes from idea to design to model. From model, it goes to construction documents. It goes from construction documents to general contracting, who break it up into subcomponents, which go out for submittal, which then go back to the GC, which then go back to the designer for approvals, which go back to the GC with modifications. And you get this insane project flow where way down here, eventually, we get to use it, or someone gets to use it. And most of the construction technology is focused on the gaps between each one of these phase gates, and they are looking to shorten those gaps. And we started with this notion, or we explored it some, but we really came up with the realization that no matter how small we made the space between those, it would not create the 2 by 2 by 2 effect that we were looking for. So we went from model to fabrication as the idea, and how would we set up a future state that would allow that to exist, because it's really more complicated than it looks. And the objective is not to work within the existing paradigm, but essentially create a new paradigm that replaces it. It's undergirded by technology. Our technology is probably the dumbest technology on the planet. That doesn't mean that we haven't been working hard on it. Amy's got much better technology, though we use a good bit of hers. But the idea is a technology platform has to undergird some of these analog processes that we work on, and we take material constraints and we work those with design constraints and logistic constraints. We go from there. All of that resides on the cloud. It turns into a digital catalog, which then turns into something that can be used by a consumer as a part. But important, a lot of people are doing this. It's not particularly new. But what's interesting, piece that we're connected to, because we're a vertically integrated design, manufacture, construction company, is we tie it also to plants, to manufacturing facilities, which then makes standard parts instead of snowflakes that Amy's talking about. And together, all of these standard and bespoke pieces reside in a digital platform that we call Weaver. All right, so this DMC continuum is important. It starts with idea, design, model, fabrication. From there, we'll break down fabrication and look at it a little tighter. If we take raw material, we use G-code to turn raw material, whether it's coil or stick, or plate, into specialized parts with digital tools. Those tools then turn into subassemblies that are put together by operators versus craftspeople. Those pieces are then added to panels. Panels are turned into modules. Modules are turned into what we call an Uber module, which is a large module, which turn into buildings. And this linear process is unnecessary to think of it this way, because I can go from raw material to a subassembly, or a subassembly to a building directly. I can bypass any of the other pieces. So the notion of what we are, or what we think the industry needs to be, is not one or the other, but simply an optimized path through the conversion of raw material to building. And there are many, many neural pathways to get there. So the kind of the next point is what do you do with DMC and how do you apply it? We use a methodology called chunking. It is not our invention. It's not even Boeing's invention, but it is something that they made famous with the 787. It's made, this really complex airplane is made in 22 chunks in 9 countries. This chunk happens to be made at the forward fuselage in Japan. It is completed down to its paint, which goes with the other 22 parts in Charleston to create what I think is the construction site of our hopefully near future, to make really complex pieces fast. Our chunk is an Uber. It's 15 feet wide and 15 feet high and 60 feet long, and it's packed with complexity. And we make it in a plant that is producing 20 of these a week. It is putting any number of them together to make one building. The resultant is space that does not look like the space that's made of the parts, but rather it can be open and well lit. medically clinical spaces in this particular case. All of that's being worked on a 400+ level of design, LOD. This is a pretty complex model. It is a prerequisite to getting to manufacturing. This red box represents one Uber of many that go into this piece. If we zoom into that, you can see that it's chock full of complexity. That complexity can be broken down into granular forms that we make as nested parts. This piece is a MEP rack, which has in it MEP parts, which broken down into a bill of material, which goes all the way down to how do I buy a copper elbow. Those pieces using a BIM 360 and the Autodesk Forge platform, we've created applications that go on top of that called Stitcher, which essentially allow us to take all of those parts and stitch that to the bill of materials, and then convert the bill of materials into G code that cuts parts. Significant amount that I just that probably should be unpacked there, but going fast. We have opportunistically looked at technology. We use digital fabrication in every place we can where it makes sense and where we can afford it. In this case, we're cutting MDF with a CNC router. In this case, we are extruding CNC coiled steel into bespoke parts. In some cases, we're using 3D additive printing to make fixtures and jigs that allow us to put sub-assemblies together. This is a quick minute of what all of that looks like right now. So this is an acute medical facility. This is a freestanding emergency department in Nevada, in Reno. It's coming in. You can see in the background the trucks are lined up. It takes about a day to set this level of modules. This is about 15 modules, and it's about a 15,000 square foot building. The piece that's being lifted up here is a roof module, which will span the big open space in the middle. It's really jam-packed with a number of complex pieces. Each one of these things kind of all go together pretty quickly to make an overall building. And when you walk through the space, it is, interesting, well lit, and kind of appropriate for what type of space it is. This is about a 5.5 month delivery from site mobilization to turnover. Typical one would be about 12 months for this type of facility. I'm going to flip over and show you what we're doing. This is a project in for Walmart Health in.
Chris, just highlighting the time.
Yep, yeah. Sure. I've got like 30 seconds. So okay, this is in a series in Georgia. What you're looking at is about a 45-day process to turn a kit of parts into an operating clinic. Those pieces are getting faster and faster. We're delivering one of these to the owner every 2 weeks right now. So it's really starting to hit a scale that the industry needed, just to kind of prove that we could open a building every 2 weeks, produce one, et cetera, et cetera. When you look at this, it's largely, this is after day 1 or day 2 in that particular spot. And then you end up with inside clinic that's finished. These don't feel like the traditional spaces that you might expect to see in this area. So that's the idea. I'm kind of in wrapping up. The last piece is that catalog turns into something that makes bigger pieces. Those pieces can be used to make steel structures that are a kit of parts, that work with modules that are a kit of parts, that nest to create really complex buildings that are site specific and hopefully high performance and beautiful. That's it.
Great, thanks, Chris. That is exciting. So are you run over by demand right now, or what's the bottleneck in getting more of these buildings out, which we desperately need?
Oh, well,
Well, it
the
seems to me you desperately need them.
yeah, the question for us is, we've been doubling in size, compounded annual growth rate of above 70% for the last 5 years, and that challenges infrastructure significantly. And every year that doubling, or it's not quite doubling, but it feels like it's doubling to us. Creates a condition where everything that was designed is now insufficient, right? So we're rebuilding this infrastructure daily. But at the same time, we're increasing production across the the whole platform. We're able to right now develop 5 programs for 5 clients, and we are producing, if you think of them as kind of volume buttons, we are able to maintain a steady manufacturing and delivery rate because we can turn up and down volume. In the beginning, it was very hard to do that. It was feast or famine. Now, as we are gaining scale, which was painful at certain points, it's helping us. So it's just taken a while, Martin. It's a work in progress.